Hi friends, welcome to A Tech Key Solution. Today we are going to start with basics. Welcome to A Tech Key Basic of neural network, and we will discuss glimpse of variety of informations of different type of neural network. So this is our channel A Tech E-Solution. Please like us, share us, subscribe us. So before start to the lecture, I will just give you the overview how the structure of these live streaming is going on. We will start from the basic and we will see all the programming concept, not go in detail in theory part. We have assumed that you will learn theory by your own, and we will concentrate on the programming part mostly. So I will go through the slides very fast and I will explain each slide hardly for 30 seconds or 40 seconds. Then we quickly move toward the programming and we will see different networks. Like first we will discuss the regression problem, then we will discuss some MNIST classifications of 0 to 9 numbers. So afterward we will discuss the programming concept which is used for object detection, localization. All those algorithm we will discuss one by one, but we will keep this streaming focused on programming part. Okay, so let's start our theory part first, then we will move toward the programming part. So go for subscription toward this channel. Please like us, share us and subscribe us, and we will start our presentation from this slide. So here I have drawn different basics of neural network. So right here, as you can see, so neural network is taken from the analogical point of view of human brain. So human brain has million or billions of neurons. So those neurons receive signals from dendrites, and the cell body is used to collect all the information and passes through the axon. So this is called axon and these are called dendrites, and this is a cell body, and axon carry all the information and those information passes through the other neurons. So these are other neurons. Okay, so this analogy is taken by our neural network to create a simple neural network. So here we take the input and we multiply this input with the weight vector and apply it to the cell body. So this cell body sums up all the information and provide this information to the activation function. Activation function is nothing but it gives the probability between 0 to 1. So we have taken an example of MNIST data set, we have taken input as 7. So the feature of 7 is represented like this, and these features are matched with the pre-trained model features. If those features are exactly matched, or if those features are matched up to 0.1% probability, then we know that this 7 has the highest probability 1. So we subtract 1 minus 0.1. So how much error it should have? 0.9. So this error goes back with the help of back propagation, and all the weights are adjusted toward this value. And further, we have calculated all the probability values right here. So let's take, we will get the probability value right now 0.9. so it is the highest probability. Now our system will predict that this is a 7. Okay, so this is a simple neural network, and here is a classification problem. Initially I have discussed MNIST dataset. Now here is a classification problem where we have 10 classes. From these 10 classes, we have taken as input as aeroplane, and we have all the labels of those images. So we train our network with labels and with images features, and we predict the output. So the original images feature is compared with the predicted images feature, and it will generate some probability value. If probability value is something 0.1 and which is less, so we back propagate that probability value to adjust the weights, and we will tune the particular value of this output layer, and all the weights are adjusted in the input layer, and we will get finally the probability of 0.7, and other probabilities are nearby 0, and one, this is a 0.3. so we predict the output aeroplane. So all these probabilities between 0 to 1. Okay, so this is the example of image classification. So next we will see there is another classification problem right here. So there are so many variations everywhere. There is a viewpoint variation, illumination, scale, and then deformation, occlusion, intrascale, and then background culture. So with the help of the CNN or deep CNN, we can generate the maps and we can classify those images. So there is another example of annotation. So with the help of CNN or any other recurrent neural network, or LSTM neural network, or RCNN, faster RCNN, so we can use those networks for creations of these annotations. So as you can see that every image has correctly annotated, and we can see this example in MATLAB and Python. Okay, then detection. Here is a RCNN, faster and RCNN, fast RCNN. This is used for the reason proposals, and it generate the boundary boxes and extract all the objects. So here is a detection of the particular object. Then there is a description, just like CNN, RCNN, or reason proposal technique is used, where each region is boundary boxed, and all the regions are annotated with the help of text information. Okay, then there is a segmentation. In that segmentation, we have to first divide a particular image and that label. So we have to define this image and label, and this image is given for the pre-processing, which use an algorithm to equal all the sizes of images, because there are millions of images or hundred of thousands of images. So if those images are not equal, then our CNN cannot work. So that's why we use pre-processing to equalize all the sizes. Then CNN, we use autoencoder for the downsampling of the image, and then we use autoencoder for upsampling. So in this way we take the input and we get downsampled, so then upsample image and we generate a particular feature map. So we will discuss this using MATLAB. Next is segmentation, where in traditional machine learning we have used different shift surf, hog. There are so many algorithms which extract the features or key point features. So with the help of those features we use the morphological operations for generating these segmentations. Okay, so with the help of a deep learning, our CNN networks, our autoencoder or decoder network generate these type of segmentation. We will discuss these things. Okay, then reconstructions, if there is a old image and some information is lost right here, so how to recreate that image. So with the help of nearby pixels, color, we can extract those features, and we will create those pictures. Next one is a restoration or super resolution. Here we have taken some patches and we have increased some resolutions of those patches, and we generate a good quality of images. There is a 3D computer vision where we have to generate a synthetic images of a particular picture. Then motion and video classification. So video is divided into number of frames, and CNN is used for the detection of video classification. Then there are so many applications. I am working on this image forensic techniques, where I have completed classification problem in MATLAB and Python. Then I have completed localization problems using CNN, RNN, autoencoder, autodecoders, and variational autoencoder. So there are different pre-trained models are also available, which I have used, which is 16, 19, FaceNet, RESNET. I will explain all those techniques in detail to you. Then there is some points of regressions, how this linear regression work. Then classification. So regression and classification, logistic, linear and logistic. Linear is in between the two, means we have to create some sample above the line or some sample below the line. It is called as a linear regression. Whereas logistic regressions, we have to create some patterns, and we have to create, this one is a class 1, class 2, class 3, class 4 and class 5. So these features are come under the this multi-layer classifications. Then non-linear regression, we will discuss those algorithms. Okay, next is a mapping in deep neural network. Thousands and tons of thousands of parameters are used to train these deep neural network, and these are highly non-linear. So data and computation is very much high over there. So there is a personal illusions. I will skip this one. There is a this is a simple neural network where we take the inputs from these values, and we multiply with the help of these weights, and we apply to these hidden layers those inputs and weights, and then we at the final we classify with the help of fully connected layer. So any network which has more than 2 layers is called as a deep neural network. So next we will discuss a convolution neural network. Convolution is nothing but we are going to create some filters, and those filters are convolved with the input image, and we pool the maximum features, and with the help of ReLU we will classify the particular feature type. Okay, so convolution operation is performed like this. In This is a complete image, as I have explained, and this image has some pixel values. We have to perform some convolution operation. So we use filter size, different filter size we can use. So this image is large, but I have taken, for example, this image shorter. So let's take an example of 3x3 filter. I have used this 3x3 filter, and I have put 1 1 1 in this diagonal. So this will extract the feature like this, and second filter is 1 1 1, and it will extract the feature like this, and third filter is this one 1 1 1 1 1, and it will extract the features like this. In this way, convolution neural network extract the features from these with the help of these filters, and we apply the strides to move the filters. As in yellow, you can see that we place the first filter, then we move the filter by 1, so we use the stride of 1. So in red, we move the pixel blocks in size of 2, so this is used a stride of 2. So in this way, we are multiplying all the values of the input image with the filter, and we will generate a particular map for those values. Let's take an example right here, that all those values are multiplied, and we will get the value like this through 2 3 4 5 6 7 8 9. So after that, each value is extracted with the help of the max pooling or average pooling. So maximum time we use a max pooling, because it generates a good type of features, because we have to take that value which has maximum representation. So in 2 by 2 max pooling, we take the highest value like 6. So from the next values, we take this 7. So in this way, we use the max pooling. Then we use ReLU. So which which probability is maximum for the each pixels, we generate a map for those pixels. So in this way, all those operations are performed. We will discuss all these operations in later slides. Okay, so this is the simple examples of different networks like DenseNet, VGNet, Inception, RESNET. So this is the VGNet information. It has 8 layer in LSTM, or 16 to 19 layers in VGNet. So 3x3 convolution filters are used with stride of 1, pad of 1, and 2x2 max pooling is used with stride of 2. So it achieves a 11.7% error rate in ILS-VRC13, and it achieves 7.3% top 5 error rate in ILS-VRC14. So this is the architecture of VGGNet. I am going to not going to explain you in detail. You can just take an overview how this VGGNet looks like. Then there is a Google Net. There is an Inception module which is used for the local network topologies, and it stack with each one over another. As you can see that each modules have different entities connected with the convolutions or pooling operation. Okay, so this Google Net network is shown like this. Okay, then RESNET is a higher training error in a deeper module. It punishes gradient as an important factor, and we can see this RESNET network is working with the principle like this. So it achieved a good accuracy at that time in 2015. Then densenet is a dense blocks where each layer is connected to every other layers with a feed forward fashion. So as you can see that each layer is connected with the other in a feed forward fashion. Okay, then there is a densenet architectures. Densenet block 1, 2, 3 are connected with the which achieve error rate of 16.4 in 2012. In 2013, there is a Pellers and Fergus used 8-layer network which achieved error rate of 11.7. And significantly the VGG and GoogleNet reduced the error up to 6.7% in 2014 with the help of the 22 layers. Then sudden jump arises in the layers. They have increased the layers from 22 to 152 layer, because right now the computation power is available, and some GPUs are available, and they have increased the size up to 152, and they are managed to get the error rate below 3 or 2.3%. So they have used RESNET and CNET, and they achieve error rate approximately 2.3%, which is very superhuman level achievement, because in human perception 5.1% error human can also be generate, and this accuracy is superhuman level. So encoder, autoencoders and decoder. What is autoencoder? As I have shown you that it is a unsupervised machine learning algorithm. So in machine learning or deep learning, we have divided the network into 3 types. First one is a supervised, then unsupervised, then reinforcement learning. As I have told you right now that supervised learning, we have input images, and we have input images, and we have labels for how you can get the output of particular image. So we have to divide each image into number of blocks, and we pass those blocks to particular autoencoder. So autoencoder will train those it encode the signals, and it decode the signal and generate the output for. Here is a convolution of UNet. There is an example of segmentations, as I have explained right here, that RGB image is given to the input layer of convolution, then batch of ReLU, pooling. So these size are segmented with different color. So this next one is a object detection network. There we have used RCNN or LSTM. Then there is a detection of segmentation, where you use segmentation algorithm. Here is a faster RCNN which detect each object separately than RCNN. So what these algorithm do, here is an image, it extract each patches and apply to convolution network, and with the help of SMM it predict the particular color size, color of or boundary box of that scene. And then yellow, real-time object detection. And there is a semis network where we have to create the positive, negative and ground truth, and we apply to these to the training for autoencoder. So this is unsupervised learning. Here is an example of this autoencoders and semis network. So this semis network is used in handwritten classifications and video classifications type of problem. So next one is a LSTM RNN network. So these networks are used in speech, text and video because they are taking the values continuously from the input. Okay, so as you can see that these values are recurrent, means we have feedback those values toward those neurons. So LSTM is a long short-term memory. So RNN can learn the recent past information, but for the long term past memory, LSTMs are useful. LSTMs are a special kind of RNN capable of dependencies. Okay, so this is all about of LSTM. And next one is a GAN. GAN is nothing but it is a generate realistic images. So GAN is a generative adversarial networks take the collections of points and infer functions that describe the distributions that generated them. So here is the example. We have taken the input 1 and 0 of real data, and we apply all the input to the discriminator network, and we generate the random generator value from the generator, and we give the input to the discriminator network, and it will mix those values, and sigmoid function is used to predict the particular value. So this GAN network is mostly used right now for the generation of ads. So conditional GANs is similar like a GAN, but it has some conditions. So conditional version of generative adversarial networks, both generators and discriminators are conditions on some data by class labels or data from some other modality. So feed y both the generator and discriminator as additional input layer, such that y the input and combinations to joint in the header representation. The additional information is constraining the generator and discriminator to generate the certain type of the output. So this generator generate the values here generative adversarial network is used here this one sentence generate the whole images of with the help of the GAN networks. This is stage 1 and this is stage 2. As you can see, each image is correctly they have predicted. So this statement is a white bird with a black crown and yellow beak. So as you can see that all the images of birds are explained right here. So conditional GAN example is used in image generations. We give the input of different peoples, and a generator will generate the output of each phase. Okay, so this is the theory part which I have explained right now. Now we are moving toward the programming concept. So let's take a look how we have started. Yesterday I have told you that we have used the Jupyter notebook. So initially you go to Anaconda. Initially you go to Anaconda, and you type you install all the packages of Anaconda like TensorFlow, then you can let's take another presentations. So let's take an example like we have taken input images. So we will discuss all those things. So we divide this section. First, we perform the basic operations like uh, basic operations uh, basic operations like uh, regression. Then we will perform classification. So in regression and classification we use MNIST data. MNIST data. So we will discuss all those things. Okay, we will discuss those things one by one. So first we are going to use regression. Regression is nothing but it used algorithm for clustering purpose. Like we have different points of different categories, so we have to draw some line. So we have to sample above and below the line. Okay, so this type of problem we have to solve. So first regression problem is given right here. So this is the simple statement that how to print a hello world. So in regression we have to first import the matplotlib and plot as a PLT. Then we have to take a numpy. This matplotlib is used for plotting. Okay, numpy is used for the numerical computation. Pandas is used for this CSV files or any image file creations, and sort all those contents in ascending, descending, or manipulations of data. sklearn is used for the data sets. So we have imported a linear model right here. So after importing this linear data, we have used the function to get the data. So in this we have defined get data function, and we have used startups. This is as a function name. So in this function we have inputted pd.read CSV file. So this CSV file is pd.csv file is available in this folder. So you can extract that file in with the help of this. This is a starter file. Okay, so as you can see right here, so this is the data. So different values are there, and this data is comma separated, so you cannot read this data right here. Okay, so how to read this data? Python use different examples. Okay, so we minimize this thing. Now this data is loaded into the folder of this data. So we have defined x parameter and y parameter. Two parameter we have defined as a blank. Okay, for single underscore square underscore feet comma single underscore price underscore value in zip data of square feet comma data of price. So if this file is in zip folder, then we have to unzip that folder and we have to select square feet and price. As you can see in this CSV file, so there is different values like R&D, spend, administration, marketing, spend, state, profit. So different states are available. Okay, so we have to take particular values of those labels which we have defined here. So x parameter dot append float single underscore square feet, then y parameter dot append float single underscore price underscore value. So we have returned here right x parameter or y parameter. Okay, so after that we have defined a linear model for x parameter, y parameter and prediction value. So in a regression we use a linear model dot linear regression. Okay, and we use a fit function for x parameter and y parameter, and we have predict outcomes equal to regr regression object dot predict function and the predict value. So predictions are represented in this way. So predictions are intercept, then there is a regression dot intercept, then coefficients, regression dot coefficient, then regression, then predicted value. So all these predictions are predicted right here, and the output is shown like this. So these are the outputs of that CSV file. So next one is the basic CNN model. We will discuss how to classify the MNIST categories of different numbers. So here you can see that we will take the first example of MNIST version first. Okay, this is the example of simple neural network. So this simple neural network use the Keras, as you can see right here. So when we start this program, it use the TensorFlow as a backend and run the program. So as you can see that this program give the output like we are collecting the placeholder for 60,000 train samples and 10,000 test samples, and how this program work I will explain you right now. So from future import print function. So print function is imported from the future. The NumPy SNP, NumPy is a numerical computation library. Then keras.dataset import MNIST. So in Keras there are different datasets are available. So we have imported MNIST dataset. Now from keras.model we have imported sequential model, then keras.model, then we have imported keras.layers.core, dense layer we have imported, then we have imported activation layer, then keras.optimizer. we have imported SGD, stochastic gradient descent. Then keras dot utils, we have imported np dot utils, which is used for text or other things, manipulations. So np.random.seed is used for reproductivity. Okay, so network and training, we have defined here the number of epoch as 2. So this epoch can be defined by the users. So it's up to you that you can increase those epoch and you can decrease those epoch. This somewhat example, so that's why we have taken the epoch size is 2, because it reduces. If we increase the epoch size, so it will take a long time, and we have defined a batch size of 128 and verbose is equal to 1, and classes is equal to 10. So why we have defined classes equal to 10? Because in MNIST dataset we have taken 0 to 9 digits, so that's why number of output of the layer is 10. Okay, so next optimizer is SGD. SGD is a stochastic gradient descent. So this gradient descent algorithm is used for minimizing the error, and we have used the number of neuron in hidden layer is equal to 128. Okay, so validation is used as 0.2. so how much train is received for the validation? So next is a data shuffle by split between the train and test. So we have shuffled the data into training and testing. Okay, and we reshape that into 784. So x train is equal to x train dot reshape 60,000 into reshape. So it reshaped into 784, 60,000 into 784. So all the output single vector is arranged in 60,000 y 784. Okay, then test is also reshaped up to this size, and we defined x train as a float value of 32, and by train is also defined as a float value of 32. Then we normalize each pixel value with the help of this 255. So x train is divided and equal to 255. Then test values is also normalized. Okay, now we print the shape of x train of 0, training sample, and we test x test is shape of 0 is also printed right here. So as you can see, we have taken all the values of these samples, and we will see how our model look like, and how's the output of our model. So this model take the sequential values, and it train over the parameters of 7850. So the output shape of the 10 neurons. Okay, so now let's run this one. Model.compile is equal to loss category, and it optimize our accuracy. Now find out the model.fit value. So now model.fit is used for the training purpose. Here we take the value of x train and by train, and we have defined earlier the batch size and number of epoch, verbose, validations. So it take all the inputs and fit the model accordingly and place the value into the history. So this accuracy we have achieved 85.46. okay, so this is the first version. So we have tested validation accuracy, and the test accuracy is 85.34 and test score is 66.33. Okay, so this happened because we have defined our model for small layers. Okay, so only few layers are defined right here. So this is the first MNIST dataset, and next we will discuss the second version of this dataset. There is a version 2. So improving the simple net in Keras with the hidden layers. Here we are introducing the hidden layers. So all the program is same as I have explained earlier, that from future we have imported the print function. NumPy we have used for the numerical computation. Keras dataset is used for accessing the dataset, and model is used for using the sequencer. A layer.core where we have imported the dense and activation layer. Then optimizer we have used SGD, stochastic gradient descent. Then utilis is used. Now from np.seed we have taken 1671 for reproducibility. Number of epoch we have increased right here 20. Initially we have taken 2, and base size is 128, bowers is 1, number of classes is 10. As the other points are similar as I have explained you earlier. We have loaded the MNIST data set and we have divided into xtrain, xtest, by train, by test, and we have reshaped that to 784, and those values of 60,000 are reshaped with 784 into 60,000. Then next value 10,000 into 784, because all the value must be same. Then we normalize those xtrain and bytrain values, and we printed the sample size of these xtrain and bytrain. Okay, then convert class vector into binary class matrices. Here we use np.utils to categorize for xtrain nv classes, bytest and nv classes. So we use the sequential model. Here we have added the dense layer and hidden layer, input shape and reshape. Then activation we have added. Then we have added dense layer activation, dense layer activation, and we have given the summary of the model. So model1.compile give the output. How this program gives the output. Let's take here this TensorFlow is working in backend, and here the parameter size is defined, and it shows that interrupt warning. Okay, it shows that delete the underlying status object from the memory, otherwise it is alive in the related status of the due to So this is the simple example of our MNIST dataset. Let's version 3 to play. So here you can, there is another error. Here this program is running for 10 epochs. So after some time it generates error because training is interrupting. My GPUs are not showing right now. Okay, but as you can see, the accuracy is increasing. uh, as you can see right here, if we increase the dropout up to 0.3, our accuracy is maximum up to 98%, and if we increase the dropout more than 40%, then accuracy will decrease. So this is the major. Next is the increasing the number of epoch. As you can see right here, if we increase the number of epoch, there is the MNIST version 1, MNIST TRP Adam. So if we increase the number of epoch, the accuracy goes up to certain level, but after that it saturate. So this is the factor for the increasing the number of the epochs. Okay, next is the collecting the optimizer's learning rate. So here we have defined the learning rate 0.1, and here we have defined learning rate 0.001. So if we define a larger learning rate, then initially our system will detect the output, but later on it will not show the output accurately. So it's up to the user that if you define the learning rate as smaller, show that your output should be with good accuracy. You achieve a good accuracy at that point in time. Okay, so next is a graph between the total parameters and the number of the hidden layers. If we increase the hidden layers up to something 512 hidden layers, so our accuracy increases, and there are some number of parameters, so the number of parameter is also increased in case if you increase the hidden layers. So accuracy is increased and computation time is also increased. Okay, so next is the executions time parameters, and here is the number of the hidden layers. As you can see right here, 1024 hidden layer, the accuracy is maximum, but the parameter is also increasing. Next one is shown right here, number of hidden layers is shown right here, and there is a accuracy. So if we increase the hidden layer up to 1024, then our accuracy will increase. Okay, increasing the size and computation. So here is a graph where if we increase here y-axis shows the accuracy, x-axis shows the number of batch size. If we increase the batch size, then our accuracy may go into decreasing way. Okay, so batch size should be 64, not more than 64. So if we increase the batch size, let's take an example of 128. At this point it is maximum, but after that if we increase the batch size, our accuracy going to be decrease. Okay, next is the model and how much accuracies these model achieve. So here is a simple model which achieve a training accuracy of 92.36, whereas validation accuracy we have achieved 90.37, and test accuracy is 92.22. As we can see from all those algorithms, we find out that Adam is the best one, and this simple one is the least one. So we prefer Adam, and it's up to user that how much or how he can define a particular optimizer. So Adam, RMS prop, dropout, these are some parameters which will increase your accuracy. Next is a concept, what is overfitting, underfitting, and this problem arises where the data set is not enough. If you have limited data set, then it's going to be overfit your model, because everything in the model is learned by the your neural network. Okay, so you have to define, or you have to create data in such a manner that your model should not be overfit. But so this is the main reason for creating a large data set. So large data set is better, because every output is classified as differently. Okay, so this is another examples of simple neural network, where we take the input and how this neural network move the weights and the bytes and give the output, and how this optimizer work is explained right here. We have features, we have model, so it predicts some values, and we have some levels. So a loss function is used for the comparison, and it generate the values, and it update the particular weights and give to the again. So in this way it explains